All right, so first of all, what we're saying is I'm going to use the double angle formula here, and we're going to do this by hand. We know how to do it by calculator using our solve function. But first of all, I can say that sine of 4x is equal to, double angle formula, 2 sine of 2x cos of 2x. So I'm now going to replace sine of 4x on the left-hand side with the right-hand side. 2 sine of 2x cos of 2x, ooh, that's ugly, is equal to cos of 2x. Now, we discussed last week that I can't just go ahead and cancel this out because I'm eliminating solutions. So let's get cos of 2x as a common factor. And let's get this cos 2x on the left-hand side. So I'm going to say that 2 sine of 2x minus 1 outside of cos of 2x is equal to 0. Now, we've got two scenarios. We've got that sine of 2x is equal to a half, or we've got cos of 2x is equal to 0. Now be careful because we've got that x is between 0 and pi. So you need to have a new working domain. And your working domain means that, okay, we know that we're not solving for 2x, we're solving for x. But you've got two equations here which you're solving for 2x. So you've got to be very careful not to just find your answer to what 2x is, because we're solving for find the exact solutions of this in terms of x. So what we need to do then is, if x is between 0 and pi, then multiplying out, because of the period being reduced by a factor of a half, then 2x is between 0 and 2 pi. So this is our new working domain that we've got here. So now what I go ahead and do is I'm just going to go and write my solutions now, but my solutions are not x. I've got 2x is equal to, well, sine of 2x. Where does 2x equal a half? Well, it's only when x, or the angle, is equal to pi on 6 and 5 pi on 6. Just using the unit circle. And cos of 2x is equal to 0 when 2x is equal to pi on 2 and 3 pi on 2. So therefore, my answer though then is dividing everything by 2. So I'm going to divide both sides by 2, which is going to give me x is equal to, and I'm going to put it in order as well, pi on 12, 5 pi on 12, pi on 4. So I'm going to have pi on 12 first, pi on 4, then I'm going to have 3 pi on 4, and 5 pi on 12. Well, that's not in order, is it? I should have had this one over here. Okay? Can I get a show of hands the students that got that correct, please? All right, can I get a show of hands, maybe the students that left the 2x and they're your solutions? Maybe one or two. Okay. So try not to make that mistake because we're asking you to solve. That's one question. Now, we went through this one last week, so I won't go through that. But what we will do is, not that one, that should be straightforward. Or do we want to go through that one? All right, let's go through this one. Now, it's saying here that sine of pi on 10 is equal to root 5 minus 1 on 4. I'm going to probably say to you that if sine of pi on 10 is that, then my pi on 10 triangle is going to look something like this. Oops. Don't forget, oops, root 5. Oh, I'm going to get the eraser out, I think. That's a bit ugly. Root 5 minus 1. Okay, so can you tell me then I've drawn my triangle, what's this missing length here? Well, that missing length is, we know that 4 squared, which is 16 using Pythag, is equal to root 5 minus 1 all squared. Be careful, root 5 minus 1 all squared, plus whatever our length is. Well, let's just call it A. So therefore, I'm going to say that 16, now you could solve in a calculator if you like, because you'd have a calculator, but I think, no, this one was an exam 1 question. So you would have been required to do it without a calculator. Root 5 times root 5 is 5 minus 2 root 5 plus 1, I think you would have got, plus A squared. So that's 6, that's going to be go to the other side is going to be 10, so it's 10 plus 2 root 5 is equal to A squared. So A should be equal to the square root of 10 plus 2 root 5. Is that okay? So this length here is 10 plus 2 root 5, and the square root of that. Yucky. All right, so we've got our triangle though. So we want to we're asked to find sec of pi on 5. So what do we do now? I guess, what is sec of pi on 5? Well, for starters, sec of pi on 5 is 1 on cos of pi on 5. We might be able to, now that we have cos of pi on 10, we might be able to use that in the double angle formula. So can someone tell me what double angle formula are we using? Yes? Okay, what, this one here, you mean? Yeah. Yes, that's right. What's that, Luke? Yes, that's right. Yeah. Okay, so what we're saying is the double angle formula is what? We're saying that sine of pi on 10, if I multiply that by 2, then as in the angle by 2, all right, so if I'm multiplying that angle by 2, that's going to give me what? That's going to give me sine of pi on 5, isn't it? So if I was to multiply that angle by 2, I'm going to get sine of pi on 5. Well, guess what? That could be sort of what we're trying to find. We know what sine of pi on 10 is. We also know what cos of pi on 10 is, don't we? So which double angle formula are we going to use then? What is it? So you're using 1 minus 2 sine squared pi on 10 is equal to what? Is equal to what? Is that sine of pi on 5? Is that right? Cos pi on 5. Okay. Good. Now, all right, so sine of pi on 5 equals 1. So now what is sine of pi on 5? We've been told that. No, we haven't. Okay. Is this cos pi on 5? Thank you. Okay, good, because there's only one for sine, isn't there? So this is cos pi on 5 is equal to 1 minus 2 sine squared pi on 10. Okay, good. Now, and sine squared pi on 10 is, so that's 1 minus root 5 minus 1 all squared was, what's that? That's root 5 minus 1 root 5 minus 1 over 16. Yes? Okay, so that's going to be 1 minus with a 2 on the outside. Thank you. So what have we got? That's going to be give us 5 minus 2 root 5 plus 1 over 16 with a 2 on the front. Good. And that's going to be 6 minus 2 root 5, 1 minus 2, 6 minus 2 root 5 on 16, which is equal to 1 minus 6 minus 2 root 5 on 8, which is the same as 8 over 8, which is equal to 2 plus 2 root 5 on 8, which we can say is 1 plus root 5 on 4. Do we agree with that? Yes? Now we're trying to find sec of pi on 5. So sec of pi on 5 is 1 on cos of pi on 5. So therefore, sec of pi on 5 is equal to 4 over 1 plus root 5. Is that correct? Do we agree? Okay, well I'm going to pause this and let's have a look at the examiner report. So in order to get this in the form that we like, we can multiply by, I guess, almost the conjugate, can't we? So let's have a look. We can multiply this expression by what? Yes, that's correct. Let's multiply that by 1 minus root 5 and let's see what happens. So therefore I've got on the top I've got 4 minus 4 root 5 over on the bottom. We know that the surds are going to cancel out. 1 minus 5 is minus 4. So therefore that's going to yield me negative 1 plus root 5. Is that correct? Okay, negative 1 plus root 5 is in this form. A and B are just real numbers. Yes, that's more like it. Now we'll go have a look at the examiner report. Root 5 minus 1. Oh, that's annoying. There we go. Root 5 minus 1. Now, why did I pick this question? Well, for starters, 61% of students got 0 mark or 1 mark, indicating that a lot of students don't have a clue what they're doing when it comes to circular functions. The second thing is the amount of students that are making stupid algebraic errors, or even the 15% of students that get 2 marks, but of course didn't answer the question in the form. In other words, they didn't know how to do the algebra to get it in that form. It was not done very well. Use of the double angle formula was students found complicated, but let's face it, 2 times pi on 10 is pi on 5. Okay? That's the important thing to remember. Once again, not done very well by students. I'm going to go and do one last question for this before I stop this video, and that question is this one here. This one. It is from 2009 exam. I'm going to pause the video. You guys, I'm going to give you 6 minutes, and I'm going to pause the video now, so away you go. So to resume, what do we do first? Well, there's a number of methods you can use, but the method which was easiest was, first of all, we could draw a triangle, or we could go straight to the double angle formula. And we can say that if we wanted theta, we can say that cos of 2 theta is equal to 1 minus 2 sine squared of theta. That was our double angle formula that we used. Please state what angle formula you're using, please. Just write that out. So therefore we can say that 3/4 Shh, thanks. It's really hard to concentrate when I've got people about 3 or 4 different conversations going. Is equal to 1 minus 2 sine squared theta. Now if I rearrange this around, I was going to get sine squared theta is equal to 1/8. Was that correct? And then I could go ahead and draw my triangle if you like. And I've got my theta triangle, and I've got 1 and I've got 8. And I know that theta, though, is in the second quadrant. So if sine of theta would be the square root of 1 on root or 2 root 2, then cos of theta would have to be negative because it's in the second quadrant. So that's negative, and using Pythag we got negative what? What was it? Something on root 7 on 2 root 2. Thank you. Okay, so we've now worked out that triangle. So you can see there that we want an expression for cis of theta, which we know is cos theta from last year's specialist, Gen A. And we now know that cos of theta is negative root 7 on 2 root 2 plus 1 on 2 root 2i. That is in Cartesian form, so we've answered the question there. And we know the important part is as well that it's negative in the second quadrant and positive in the second for sine. So our answer is that, or other equivalent answers would be accepted. In terms of the examiner reports, as we just discussed, a number of students couldn't get started on this question. And those students that did might have made some silly errors, particularly with the signs, and all round wasn't done typically that well. Such a simple question. All right, I'm going to stop there. I'm going to stop